This one is C11H14O2. It has 5 double bond equivalents. We have a 4H that's in the aromatic region. It's going to be C6H4, so an aromatic ring with two things attached to it. We have a CH, and we have a CH3 and then two CH3s over here for the 6H. Now when we're deciding if we're going to have two CH3s or three CH2s for a 6H, you should look at the number of peaks. When there's one peak, two peaks, or three peaks, most likely two CH3s will be what the 6H represents. It's only in the case of 4 peaks that we would consider 3 CH2s for our 6H. If you'd like, you can stop the video and you can read my discussion about this and how it relates to symmetry arguments. So that means we've got a total of 3 CH3s. Now over here we see we've got a C, two O's and a double bond equivalent. That's what's left over. So a C double bond O and an O. Everything counts down to 0. These should be the correct pieces. Alright, now we've got to put everything together. Now one thing that we know here is we've got a CH and it's got 7 peaks. That would indicate that the CH is connected to a CH3 and another CH3. So that would be 7 peaks, which means we have 6 adjacent hydrogens, so these two methyl groups. Now we've got to figure out where the rest of this goes. Now another clue we can look at has to do with where this CH is located. We're looking probably at an ester grouping since we've got a C double bond O and an O. So let's take a look at my discussion of ester groups and where we can expect to find the peaks. So let's say we've got this kind of situation where you've got a CH2 directly connected to an oxygen. This one is going to be at 4 ppm, around about 4 ppm, and this one here is the methyl group CH3 attached to a C double bond O. You'll expect to find that between 2 and 2.5 ppm. So bottom line, whatever's connected to the O will be at about 4 ppm. You'll notice that the CH peak is at about 4 ppm, so that would indicate that it is next to an oxygen atom like this. So once we put the anchor in, all that we need to decide then is where the rest of this goes, whether we have this here or whether it's switched around and we have the C double bond O over here. Well, we're not going to get a whole lot of information from the chemical shift of the CH3. It's about 2.1, which is kind of similar for both an aromatic ring or a C double bond O. So what we've got to do is look at the aromatic ring and see what kind of clues we can get from that as to what might be connected to it. And one thing I can tell you is that when we're looking at aromatic rings, I know this is a different case because it's only one thing connected to the aromatic ring, but similar arguments can be made for the case we have where we've got two things connected to it. But what I'm saying here is in the case of a C double bond O connected to the aromatic ring, you'll see that the aromatic ring gets split into 2 peaks, and those are centered at around 7.7 ppm. In the case of where an O is directly connected to the aromatic ring, it's split into 2 peaks and it's centered at around 7 ppm. The alkyl group is just going to be a single unsplit peak at somewhere between 7 and 7.5 ppm. So what I'm looking at here in this instance would be an alkyl group and a C double bond O. So you'll notice that we have a peak at around 7 ppm and then a peak that's at around 7.8 ppm. So that tells us that a C double bond O is most likely attached to the aromatic ring. What we have to decide though is what's more likely, whether we have a C double bond O and an O, or whether we have a C double bond O and an alkyl group. I'm going to bet that in this case, even though it's very subtle, I would put the alkyl group on one side and the C double bond O on the other, only because of the placement of this peak here. Since it's a little bit after 7, I would say that's more likely indicative of an alkyl group, whereas if the O was directly connected to the aromatic ring, I think that this peak would be a little bit less. It would be probably somewhere in this region down here, based on the discussion I was showing you earlier. So that would be my bet, is that we would handle it in this fashion.